6-8 is a lesson on interest. We're going to look at two kinds of interest. Simple interest and compound interest. This one is pretty simple. Compound interest has a pretty complicated formula that you'll have to use and substitute values in for the different variables, and then work through that using the order of operations. So let's look at simple interest. This is the kind of interest that you pay when you purchase a car. You know, if you're going to take 60 months to pay for it, they'll tell you what the interest rate is. That's an annual interest rate. That's how much you pay on the original principal or the original amount every year. And if you're taking it for 60 months, that's 5 years. So you would pay that 3% interest, for instance, the first year on the amount of money that you needed to borrow to buy the car. You would pay it again on that amount, and again and again and again. It's pretty simple to figure. The simple interest is just equal to the principal times the rate times the time. And that's how you find the simple interest. This is the formula to find out how much you would be paying in the end, where you paid the principal back plus this interest that you would owe. So I is the amount of interest, P is the amount of the principal. This is the amount of money that you borrowed, or if you were the bank or the person with money in your pockets, then that's the amount you would loan to somebody. The R is the annual interest rate. And of course, we'll use it in decimal form, but this is how much interest every year. The time will be in years, and the A would be the total amount in the account, even like if you're saving money, and they just add all the interest that you made back into it. That would be the total amount. Or if you borrowed money, say, to buy a car, that would be the total amount that you would be paying by the time you repaid the loan and the interest for borrowing the money. So again, we have a little chart, and we know that the interest is the principal times the rate times the time, and the total amount is the principal plus the interest. So here we have the principal, and we're going to multiply it by the interest rate, but of course we're going to change this from a percent to a decimal. And this is how many years. And then we would multiply this times this times this, and that would give us the interest. And then we would add the interest plus the principal. So we would add the principal and the interest, and that would say how much the total amount would be. So we'll start with the first one. So the principal is $2,000. The interest rate is 7% or 7/100, and it's for 3 years. So we're going to multiply on our calculator. 2,000 times 7/100 times 3, because it's 3 years. And we find out we're paying $420 in interest. Now, so how much that will be in the end, how much you will have paid, you'll add the $2,000 and the $420, and you'll get $2,420. The next one, $3,500 or $3,500 times 600 times the time is 4 years. And the interest would be $840. And now to find the total amount, we're going to add that to the $3,500. And it would be $4,340. The next one, it's $10,000 at 7% interest, or 7/100, and it's for 6 months. Remember, the time is always in years. So 6 months is what, a half a year? So I'm going to use the decimal. I mean, you can divide it by 2. That would be another way to do it. You could multiply by 1/2. I mean, that's what we're going to be doing if we multiply by 5/10. So I'm going to put in 10,000, and I'm going to multiply it by 7/100, and I'm going to multiply that by 5/10. And our interest is $350. So the total amount, that is the principal plus the interest, would be $10,350. Okay, I'm looking at the next one. Our principal's $20,000. The interest rate is 3.5%. We're going to move that decimal point 2 places. 35 thousandths. And it says 66 months. We want to be sure that that's in terms of years. So I think that 5 times 12, 5 years would be 60 months, and then we have another 6 months. So this is actually going to be 5.5 years. 5 years would be 60 months. 5 times 12 is 60, and then the 6 months left over is a half a year. So it's 5.5 years. So here we go. We're going to multiply this times this times this, and we're going to get the interest that we would have to pay. The money that we have to pay for using that money, or maybe we're the rich ones and we're loaning it, you know? 5.5 years. And the interest rate is $3,850. And when we add that to the principal, we get to $23,850. So this interest is what's added on to the ticket price of your item, or, you know, if you're taking out a school loan. Depending on where you get it, the lender will set the interest rate, and together you'll decide how long you need the money for. Sometimes you can, if you pay it back pretty quickly, of course you don't pay as much interest. If you borrow it for a long time, like some house loans are for 30 years, so you would, you know, that would be 30 sets of 1 year of interest. The next part, compound interest, is more complicated, but if you are the like the person saving money and you're getting paid compound interest by the lender, or like the bank, when they're saving your money, then you will get more for your money. You get more return on it. So the interest is computed not only on the principal, but also on the interest already earned in previous compounding periods. Compound interest is used more often than simple interest. I don't know about that. It just kind of depends on what you're talking about and where your money is and where your money needs are. So let's take a look at what happens. Suppose we have $2,000 invested at 7% interest, compounded annually for 3 years. So that means that the interest is paid annually, or one time a year. So at the beginning of the year, the first year, we had $2,000. We got an interest rate of 7%, or 7/100 times 1. We'd get $140 interest. So what happens in compound interest is they're going to add that. they're going to add that to the $2,000. So at the beginning of year 2, we're earning interest on $2,140 instead of just on $2,000. So we know that's our principal now. Our interest rate is 7% or 700, and for another year, we would earn $149.80 in interest. So now this is being added to the principal. And now for the next year, we have $2,289.80. I think this is the zero that goes over here. So this is our principal now. We're getting paid 7% interest on that for a year. So if we multiply this times this times this, we get $160.29, and that will then be added to the value at the end of the year. So now we have $2,450.09, which is a lot when we started with $2,000. So as you can see, we get more interest each year because our principal is growing each year, and it's growing because we're adding the interest from that year to the principal. So it's really earning interest on the interest, and it does add more, it does earn more than just simple interest. So if we just had a couple of years, it's not that troublesome. I mean, it is some trouble, but not beyond our, what we could do. But if you had money that you were investing for 30 years, you would have to do that 30 times. And so mathematicians have come up with a formula. Here's the formula. You can see it is a little bit complicated. We've got parentheses, we've got addition and division, we've got multiplication of the numbers that are going to be used as the exponents. So we have a lot of things to do. And of course we're going to use our calculator, but we have to know how to run it, so we're all running it the same. So each time we work one of these problems, we're going to write the formula. This is the formula. I'm going to ask you to show the substitution. What numbers go in here? The A will be your answer, but P will be the principal. R, which is here, will be the interest rate written as a decimal. And T, that's in the exponent, will be the length of time in years. And then this N is a new piece for us. It's the number of times compounded per year. So sometimes it's just paid once a year. That's what we did on our little example that we looked at earlier. Sometimes it's paid twice a year, so that interest is added twice a year. Sometimes it's paid quarterly or 4 times a year. So you figure the interest and then it's added on to the principal 4 times during the year. So we're going to write the formula, show the substitution, and then be sure to label our answer, of course. Okay, here we go. First problem. $1,000 is invested at 8% interest, compounded annually. That means once a year, for 3 years. Find the total amount of the account after 3 years. So we'll write our formula. This is going to be our exponent. Now we're going to substitute what it's told us in the problem. We're going to be finding the amount, so we don't have a number yet for that. The principal is 1,000. R is for the rate, and it's 8%. So we'll change that to a decimal. And we're going to divide it by the number of times that it is compounded each year. And that is going to be, annually would be 1. And now for the exponent, we have this number of times compounded times the time. And in this case, it's 3 years. Okay. So I need these two things and I need your answer. But there's some work that I like to show on the way so I don't get confused. So I'm just going to work this for you just like I would. Okay, we've got 1,000 times. And I'm going to do, of course, what's in parentheses first. And I know that 8 hundredths divided by 1 is 8 hundredths. And if I add 8 hundredths to 1, that's what all this in the parentheses is. And my exponent is 1 times 3, or 3. So now I need to do the exponent next. So I'm going to take 1 and 8 hundredths to the third power. And I'm getting this number. I'm just going to leave that in my calculator, and I'm going to multiply by 1,000, which is really just going to move this decimal point 3 places to the left. But I'm going to do it on my calculator just to be sure. So the total amount is 1,259, and I get this on the end. So we're going to round at the very end. We're not going to round until the very end. So if we rounded this to the number of cents, 71 or 72, the 2 says to stay at 71. So I'm not going to round. I'm going to round at the very end. Okay? Let's look at the next one. Again, we're going to write the formula. I can do that right now if I need to. I'm going to show the substitution, so I'll have to figure out what these letters stand for. And then, of course, I'll label my answer as dollars in the end. So, now we need to substitute. $2,000 is what's invested. Now I'm looking for the rate, which is 5%, and I'm changing that to a decimal. And the number of times compounded annually, it's compounded annually, so that's once a year. And now the exponent would be 1 times 3 for 3 years. Okay. So I'm going to show a little work here with this. I need this one, and I like to write some of this other stuff out so I can kind of keep myself straight. So we have 2,000, and I know I'm going to do the parentheses first. I have 5 hundredths divided by 1, which is 5 hundredths, plus 1, which would be that, and 1 times 3 would be 3 for the exponent. So I'm going to take, on my calculator, 1 and 5 hundredths. I'm going to take that to the third power. I'm just writing this out here. Now, I'm not going to round. I'm just going to leave this in my calculator. I'm going to leave it in my calculator. If you round here, it's going to be different than if you don't round. So we're going to leave that where it is, and I'm going to multiply 2,000. And that's going to give me my answer. The total amount is 2,315 and 25 cents. I mean, it came out that time to the exact penny. Sometimes you'll have to round your answer. This one had 71 and 2/10 cents on the end of it, and I had to round it to the nearest whole cent. This one came out with whole cents at the very end. All right, we've got another formula. Again, we're going to write the formula, show the substitution, and label the answer. So I'm going to write my formula. I just copied my formula down, and you'll be able to have this formula so you don't have to memorize it. And now we're going to substitute. It says that the principal is $8,000. The rate is 5% or 5/100ths. And it's compounded quarterly. And quarterly means 4 times a year. And we're going to do it for 1.5 years. And to make this simple, I'm going to change that to 1 5/10. That's 1.5. Okay, so now I'm ready to start my calculations. I'm going to do what's in parentheses first. I'm going to start with 5/100ths divided by 4. And I get 125 10,000ths. Added to the 1 would be 1 and 125 10,000ths, and I'm going to take it to the 4 times 1.5 power, which is to the 6th power. So I've just multiplied these. That's how I got the 6. I divided this and added 1 to it. So next, after the parentheses, now I'm going to do the exponent. So put that number in, and now I'm going to take it to the 6th power, and I get an entire screen full of numbers. I'll show you what I got. So I know that it goes on and on. So I'm leaving that in my calculator. And I'm going to multiply it times 8,000. And my answer is $8,619. And then it has 065444. That's what it's showing. So I want 2 places for the cents. And the 5 says go up. So it's going to be 7 cents. Okay, we've got one more. Actually, it's built on this one, and there's a little typing error here. The total amount in the account after 30 years. So we figured this on 1.5 years, and now we're going to change that to 30 years. So we'll write our formula. And now we'll substitute $8,000. 1 plus, the rate is still 5%. And we're still compounding quarterly. And our exponent will be 4 for quarters, and the time now will be 30 years. So when we do this on the inside of the parentheses, we're going to get the same thing. And our exponent, 4 times 30 would be 120. So we're taking it to a pretty high power. So I have 1.0125 to the 30th power. And this is what I'm getting, 308022, and it fills my screen, so there's probably more to it. I'm leaving this in my calculator. I don't want to round yet. Because if I round here, the answer is going to be different. And the institution will not round one way or another. And I'm going to take this number times 8,000. And I am getting $12,504, and I have 64176 that goes on. So I want to round this to the nearest penny, and the one says stay the same, so 64 cents. So you can see, because this was for 30 years and this was only for a year and a half, I've got a lot of money, don't I? I've got a lot of money. So that's the end of chapter 6, and we're going to do the end of chapter 7 next.